Okay, let's move on to talk about abstract classes. Some rules here. An abstract class, as you have seen just now, you declare an abstract class using the abstract keyword, may not be instantiated. Now, which means that you cannot create a new instance using a new keyword, okay, of an abstract class. May contain any number of concrete and abstract methods. In other words, once you can have any number of abstract classes, including abstract methods, including none. You can have any number of concrete methods, including none, in an abstract class. Okay, an abstract class may be empty, meaning it has empty body. Fine, that's possible. An abstract class may contain attributes and constructors like normal concrete classes. All right. So let's take a look. We have seen an abstract class just now, communicator. Alright, it is an abstract class by virtue of this keyword here. And since it contains two abstract methods, it must be an abstract class. Otherwise, you get a compilation error. Alright, because you cannot have abstract methods in a normal concrete class. Now let's try to compile a communicator. Alright, no problem so far. Now let's try to test the first rule, that you cannot create an instance of an abstract class. So I have a test class with a main method. What I'm doing here, I'm declaring a variable called C, and it is to store the address of a new communicator object. Let's try to compile tests and see the compilation error. And it's exactly what it says. Line 4 is a statement of a new keyword. Communicator is an abstract class. Hence, you cannot instantiate. That means you cannot create a new instance of it. Pointing to the new keyword, there's an error there. Alright, so what's the point of a class which cannot be instantiated? Well, you'll see much later that you can extend an abstract class. Alright, so abstract classes can be used for extending. Abstract classes are useful when you want to declare a variable of that type. Okay, hold on to that. So let's write another class called cellphone. Public class cellphone extends communicator. So cellphone is a subclass or a child class of communicator, which is an abstract class. Now, because of this, these two abstract methods called sendMessage and displayInfo would be automatically inherited to cellphone. No surprises so far. Alright, inheritance. Do you think I can compile cellphone? Let's try. Again, an compilation error. Very you have to understand why. It says cellphone is not abstract. Alright, it is a concrete class because I did not use the abstract keyword when I declared cellphone, and does not override abstract methods display info in communicator. Actually, only picked up the compiler only picked up the first method, and not the second. But it doesn't matter. What the compiler is trying to say is that this is a concrete class, okay, but it has inherited two abstract methods from communicator, and hence cellphone has got two abstract methods. Now remember the first rule we talked about. This one. A concrete class cannot have abstract methods. Of course, that includes abstract methods inherited to you. And that is the reason why you got this compilation error. So, two ways to remedy the situation. First way is to make cellphone abstract. This will work. Alright, but of course, you may not want this. You may not want to make cellphone an abstract class. You want people to be able to create a new instance of cellphone. Okay, that will, if you make cellphone an abstract class, this will compile. Okay, because an abstract class can contain abstract methods. Now the second way to solve the problem is to override. Remember method overriding? Override the two abstract methods. So let's copy them. Okay, when you override a method, the method signature must be the same, of course, without the abstract keyword. Now instead of a semicolon, you open and you close to provide a body. Alright, and what should send message do? Basically, for this demonstration, it prints out a message sending um, message to target number. Right, a cell phone and SMS. Okay, a cell phone sends a message via SMS, and then it returns true. It has to return true or false, right? Now in this case, okay, it's a bit silly, but I always return true. You can change the code so that if the sending of the SMS fails, you return false. Okay, but that's not the point here. Um, these two lines can be replaced with any code, okay, which simulates the sending of an SMS, all right, to the target telephone number. Now, what about display information? I'm going to override it. Remember, remove the abstract keyword of when you override no abstract keyword. It becomes a concrete method, and it prints out information about the cell phone. Okay, this is a cell phone, for example. Okay, something dumb for now. Now, what I've written here is um, a concrete class which inherited two abstract methods called sendMessage and displayInfo, and I've overridden both of them in cell phone. Hence, cell phone no longer contains abstract methods. Cell phone contains concrete methods and should compile. Let me save and compile cell phone. Oops, capital P. No problem. Alright, and you can create a new instance of cell phone and use it, call the methods and so on. So I can have okay, hold on to that. That's no big deal. It's not interesting. Now, what about another class? I've written a class called fax machine. All right. Fax machine is a concrete class which extends communicator. Okay, and similarly, you must override the two methods inherited from communicator with concrete bodies. So I've overridden them. In the send message method, I'll print sending a fax message, no more SMSs. A fax machine sends fax messages. It cannot send SMSs. And display info, probably I'll just say I am a fax machine. Okay. I've written a third class called a message pager. A message pager is a communicator as well, extends communicator and overrides the two abstract methods inherited, send message and display info. Okay, let me make minor modifications. Sending a text page to, okay. Probably you guys haven't seen a message pager, but it used to be the thing of the century about 20 years ago. Okay, you can send text messages via pager. Anyway, so we have got three types of communicator devices. All right, all of them extended communicator. How does this look as far as a class diagram is concerned? All right. Now, one thing, when you draw a class diagram of an abstract class, the name of the class has got to be italicized. An italicized name means that this class is an abstract class. All right. You can notice my attempt at cursive writing here. And these two methods here, same thing, italicize them. Okay, they are public methods because there's a plus there. And this tells the reader that these are abstract methods. Okay, so this diagram shows the relationships between the four classes. Communicator is abstract class. Cell phone extends communicator, fax machine, and message pager both extend communicator as well. All right. Now, because of this relationship, because cell phone extends communicator, you can be very sure that cell phone will have the two methods called send message and display info. Same for fax machine, same for message pager. And you can be very sure that in all these three child classes, these two methods have been overridden and given a concrete body. Otherwise, these three classes cannot be concrete classes. So realize that we are enforcing certain rules. Okay? Okay, one last thing about abstract classes. Now you can't create an instance of an abstract class. We have talked about that. You can't do new communicator. But useful thing here, you can declare an object reference variable of that type. What do I mean? Okay, you can do this. Communicator C. You can declare an object reference variable called C, or whatever name, of this type. And what can C store? It can store the address of any communicator object. You can't create a new instance of communicator, but you can create a new instance of cell phone, and that object's address can be stored in C. C can store the address of a cell phone object, a fax machine object, for example, okay, as well as a message pager object. Alright? Because a message pager is a communicator, a fax machine is a communicator, a cell phone is a communicator. Hence, this is fine. Okay, communicator C equals to new fax machine. So C becomes a very flexible variable because C can be used to refer to an instance of a fax machine, an instance of a cell phone, or instance of a message pager. This makes C flexible. An example. Okay, I can do something like this. Equals to new cell phone. Okay, and I can call using C the method send message, and I'm trying to send a message testing to a number called 1, 2, 3, 4, 5, 6, 7. Let me try to compile this. Java C test.java. Oh, I forgot to close it. This is dumb. And the telephone number is a string. You see, when I call the send message method of C, the send message method, okay, of the cell phone gets called, and it says sending an SMS. The message is testing to this number 1, 2, 3, 4, 5, 6, 7. Alright, some of you may be wondering, this is pretty weird. If you know that you're going to create a cell phone object, why don't you just, declare a variable of this type? And there would definitely be no problem. Now, the issue here is sometimes you may not know what C might be used to store. Okay, let me give an example. I've written some code here. Okay. Okay, instead of creating a new instance of cell phone or message pager, I will call the method called acquire communicator. Okay, I'm going to write another method which can be called directly by main. This method is called acquire communicator, and it returns a communicator object. Okay, it can be any of the three. It can be instance of a cell phone, instance of a message pager, or instance of the fax machine. Now, some silly code here. I generate a random number, okay, which using the random class, random object, and the random number is from 0 to 3. So if random number is 0, it will create a new cell phone object and return it. If random number is 1, it creates a new fax machine. If random number is 2, it creates a new message pager object and returns it as a communicator. Alright, either of these instances will be returned as a communicator, and address is stored in C. So this is an example whereby you are not sure what object will acquire communicator return, but you are very sure that it will return a communicator object which can be stored in C. And then you call the send message method, and this will either print out sending an SMS, sending a fax page, or sending a pager text, stuff like that. Let's try to compile this. Compile test. Oh, okay, cannot find symbol random because I failed to import java.util star. Okay, the package for random. Let's try again. Okay, compilation is successful. Running. In this case, acquire communicator return a cell phone object. It's running again. In this case, the acquire communicator method returned a fax machine object. Okay, a cell phone object. Oh, sorry, I said something wrongly. The first instance, in the first instance, it returned a message pager object. It returned a fax message object, and then lastly, it returned a cell phone object. Of course, this is all random. All right. This is a silly example. What I'm trying to say is, C is a flexible variable now. Okay, it can be used to store the address of any communicator objects. So that's for abstract classes. Oh, by the way, one last point, it is possible to extend an abstract class and create another abstract class. Okay, no problem with that. In fact, you can extend a concrete class, all right, to create an abstract class as well, if you want to do that for whatever purpose. So that's all. We'll move on to interfaces next.